So a problem that was in our class notes from 223 had a retrosynthetic analysis and forward synthesis question shown here. So essentially, you need to look at this and work backwards to get to this starting material. So the first question you guys ask yourselves: do we add any carbons? Do we add any carbons? Any carbons added from the starting material of the product? I think we didn't add any carbons. If anything, what did we do? We actually lost carbons here. How many carbons do we lose? How many carbons are not in this product that were in the starting material? Two, right? Looks like there's a carbon here and a carbon here, and they are gone. They are not here anymore. So that should give us a tip about something, right? You only know a couple ways to lose carbons, but maybe try to remember that stuff. Also, if you look here, this is an aldehyde. You recognize that's an aldehyde, and you recognize this is a secondary alcohol. So that should also kind of tip you off. Like, wait a second. An aldehyde in the presence of a secondary alcohol is unique because, right, usually aldehydes are more reactive than what did this secondary alcohol come from? You only know a couple ways to make secondary alcohols. What does a secondary alcohol come from? What starting material would you use to make a ketone? That's right. This comes from a ketone. But how could I get a ketone to react in the presence of an aldehyde? That should also be a clue. How could I get a ketone, right? This is an aldehyde, and this came from a ketone. How could I make that happen? Protecting groups, right? So that's the first step back will be, okay, I must have had a protecting group on that aldehyde. To get that, I must have had that mask on to protect that aldehyde. And then one step more back would be this with the mask on. And if we go back one more step, it would be the part where we put the mask on in the first place. So now we have these two carbonyls, a ketone and an aldehyde. Now how do we get those? What are the ways to get ketones and aldehydes? And remember, we've lost carbons. Remember, we talked about this. We lost carbons. Where would they come from? How can you make carbonyls? What's one of the ways to make carbonyls from this unit? So there's multiple ways we could do this. We do have to do one thing first. So you can say, I would guess this could come from, you got to be careful actually here. I'm thinking ozonolysis. That this would have came from this and this. Right? And now this could have came from that. Maybe. Right. So what reagents do we need going forward then? How do we take an alkyne and make it an alkene? Stop it at alkene. What could we use? H2, but it can't be palladium on carbon because if it was palladium on carbon, that would reduce this, and it would reduce them both all the way to alkanes. How do we stop at alkene? H2 palladium on carbon. What was that reagent? What catalyst was that? Lindlar's, right? Lindlar's catalyst. Right? Lindlar's catalyst stops at the alkene. Right? And that wouldn't affect this, so it's going to stay at the alkene. We have alkenes. We can turn those into carbonyls by adding O3, ozone. Now, if we want to put the mask on, we need H+, it's a catalyst, and we need that alcohol. So what's that alcohol look like? Like that. Now that the aldehyde is masked, it's not going to react. What do we need to do to reduce that ketone? What reagents could we use? There's actually two reagents we could use. If you use lithium aluminum hydride, that would actually save you a step, right? So there's two ways. Let's do. If I did the lithium aluminum hydride, that'd be the blue line. That'll actually get you all the way to the final thing, because step 1 for lithium aluminum hydride is 4. Then step 2 is H plus, right? And H plus is going to take off the mask. So you could lithium aluminum hydride gets it all done in one step, reduces this, and then during the workup it breaks this down back to the aldehyde. Or we could do it by stepwise. We could have NaBH4, and then we could add H plus and water here, and then need to be H plus water here as well. Take the mask off. All right, so this one does the reduction in one step, and the next step you'd have to add H plus and water right, because the water is going to take off the mask. Obviously, the water is in excess. Or you could do lithium aluminum hydride, which would also reduce this, which requires H plus and water, which will also take off the mask too. All right, so the key here was recognizing aldehyde and a ketone, and that means you knew you needed to use some sort of protecting group, that acetyl protecting group, the mask, to control which reacts first and which reacts when.